Hi friends, welcome back. So today we are going to solve the entire transportation problem using Modi method because they are asking to solve the entire problem, not just the initial basic feasible solution, initial solution. Okay. Now, before we go to that, let us see what are optimality tests and in what all ways we can solve the optimality test, and let us come back to the problem here. So the optimality tests, now here you can see that once the initial feasible solution has been computed, how do you compute? Using northwest corner rule, the least cost method, or the WAM method. Once we have done that, if they ask you, the next step in the problem is to determine whether the solution obtained is optimal or not. What are optimality tests and how they can be achieved? Optimality tests can be conducted on any basic feasible solution. Now, the main criteria for optimality test is the solution of initial solution should be basic feasible, of the transportation problem provided. Such an allocation has exactly m-1 non-negative allocations. Also, these allocations must be independent positions. Now, there are two methods to have optimality test, that is Modi method, and another method is stepping stone method. In this video, we are going to solve the problem using Modi method. Now, Modi method is an optimization technique used to find the optimal transportation cost. In Modi method, we modify the existing initial basic feasible solution IBFS by optimality test to find the optimal solution. Now, here are the steps to solve the problem by the Modi method. We will try and solve the problem using this. The first step is find the initial basic feasible solution of the transportation problem by using any one of the three methods, that is NWCR, LCM, or WAM. Check whether the solution is basic feasible solution or not. Okay, if it is not a basic feasible solution or non-degenerate solution, it will be degenerate solution, which is not possible to solve the further problem. You need to have basic feasible solution, that is non-degenerate solution. Only then you can go ahead with this. The best method to go for the Modi method or the stepping stone method is you should solve the initial solution by WAM. WAM is the best method. Than NWCR or LCM, WAM is the most preferred method before you go for solving the Modi method. So in our problem, given problem, what we are going to do is solve the problem by WAM and then go for the next steps. So let us see how to solve the problem using WAM in this particular problem. Alright, so here is the problem. Let us write solution here. Once they give you the problem, you can write once more and write solution. And how to solve by WAM? So first thing, we need to see whether there is a feasible solution or not. So let's total this of 4 plus 3 plus 4 plus 4. Okay, summation of demand is equal to 4 plus 3 plus 4 plus 4. That is equal to 15, and summation of supply is equal to 3 plus 7 plus 5. That is also equal to 15. Therefore, summation of demand is equal to 50 is equal to summation of supply. Therefore, there exists a feasible solution. Once we know that there exists a feasible solution, we can go ahead with the WAM method. So let us do the WAM method now. So the total is 15 here. So it's a balanced transportation problem. And in our previous videos, we have seen if it is a non-balanced transportation problem, how to balance it. Now, first we need to, in WAM method, when we are solving the problem using WAM, we need to have penalty costs. So here P1, here also P1. So once we are seeing this particular row, we need to see the minimum least cell, least valued cell. This is the least number in the cell, that is 1. The next to it is 2. 2 minus 1 is 1. The least cell value is 4 here. The next least value is in this particular row is 5. 5 minus 4 is 1 again. So here the least number is 6. 7 minus 6 is 1 again. So here in this row least value is 2. Next to it is 7. 7 minus 2 is 5. Here it is 6 minus 2, that is 4. Then here it is 5 minus 2, that is 3, and 4 minus 1, that is 3. Anyway, we know how to solve the problems through BAM method. Now, which is the highest penalty cost here in this particular iteration? 5 is the highest, so I'll put a small arrow kind of a thing here, so that I will know later that I'm trying to solve the problem through this method. So, which is the least value in this particular column? It is 2. So, let us allocate for 2. So, 4 and 3 is there. The least is 3. So, I allocate 3 here. 3 is gone. So, I'll strike this off. So, 4 minus 3 is 1 remaining. So, I have done this for particular this thing. Again, I have to go for the second iteration, P2 and P2 here. So, first one is dash because the first row is exhausted. So, I'll go to the second row. So, 4 is the least. Next to it is 5. So, 1. So, here also 7 minus 6 is 1. Here in P2, this particular row is exhausted. So, we need to see only these two. So, 10 minus 7 is 3. 8 minus 6 is 2. 5 minus 6, 6 minus 5 is 1. 8 minus 4 is 4. Which is the highest penalty cost in this iteration? The highest penalty cost is 4 here. So, we need to do allocation for 4. So, I'll put a small arrow kind of thing here so that I can know. So, in this one, which is a minimum cell value, least cell value, that is 4. So, I need to do the allocation for 4. So, 4 and 7 is there. How much I should allocate? 4. So, if I take out 4, this goes off. 7 minus 4 is 3. So, in the same way, 2 by 3 matrix is remaining. For this, I need to do one more iteration, that is P3. Here it is dash. Here the least value is 5. Next least is 8. 8 minus 5 is 3. Here in this iteration, this is 6 is the least value. 7 minus 6 is 1. Okay. So, in this next one, if we see here, 10 minus 7 is 3. 8 minus 6 is 2. 5 minus 6 is 1. And this is dash because this is already exhausted. Now, which is the highest iteration here? Here there is 3, and here also there is 3 here. So, any one I can take. What I will do is I will take this one. Okay. Once I take this one, here in this particular row, 5 is the least cell value. So, I will allocate for this one. So, here it is 4 and 3. I have to allocate 3 here. So, this goes off. I have to strike this. Then 4 minus 3 is 1. So, I should go for the next iteration, that is P4 dash. This one will be dash. Both the cells are rows are exhausted. Here in this one, least value is 6, next is 7. 7 minus 6 is 1. Similarly, here, so there is just single column, so you have to copy the same thing, 7, 6, 6. Okay. This one will be dash. So, when you do allocations for the last column, it is, you have only one this thing, that is 7 here. This is the highest frequency. When you go inside, there is only one cell here which you have to do the allocation. Here there is 1 and here there is 5. The least is 1. You will do allocation 1 here. This becomes 0. and this becomes 5 minus 1 is 4. And we need to go for the last iteration, that is P5. That is, this one is dash, this one is dash. 6 minus 6 is 0. Okay, and take P5 here. This is dash, this is 6, this is 6, and this is dash. So you can take any one from here. I'll take this one. So let me allocate 3 here, 3 and 4. So to allocate 3 here. Once I allocate 3, this becomes 0, and 4 minus 3 is 1. So the last cell remaining, I don't have to go for another iteration here because 1 is remaining, last cell. So I'll allocate 1 here. So this is the solution. This is the solution what I got from the VAM method. Now what I have to do is find out the total cost here. So to find out the total cost, I will take this entire thing off so that I can have more space. The total cost is equal to 2 into 3 plus 5 into 3 plus 4 into 4 plus 7 into 1 plus 6 into 3 plus 6 into 1. So how many? 1, 2, 3, 4, 5 and 6. So 2 3s are 6 plus 50 plus 16 plus 7 plus 18 plus 6 plus 6, that is equal to 68. That is equal to 68. So once having found this, we need to go for the next this thing, that is whether the solution has a basic feasible solution or not. So how to find out whether the solution is basic feasible solution? We need to see the number of allocations. Number of allocations are 1, 2, 3, 4, 5 and 6. Number of allocations is equal to 6. So m plus n minus 1 is how much? 3 plus 4 minus 1, that is 7 minus 1, that is 6. So both are same. So that means that there exists the basic feasible solution. So we have done the first part. We have done the VAM, solve the problem through VAM method, and then we have actually got the basic feasible solution also. So what is the next step what we have to do here? We have to solve this entire problem, go to the next one. This is the initial solution. We have to test for the optimality. So for this I will rub this entire thing off. Okay, let this be there. Yes, okay. Now let us go back. I'll just take this off as well. So now we have rewritten the table so that it becomes very clear after allocations. Now we'll go back to the steps and see what is the next step, second step. So the second step is find out the set of numbers ui and vj for each row and column satisfying ui plus vj is equal to cij. So this we have to do especially for each occupied cell. We need to remember this. We need to do for only the occupied cell. These two steps are for the unoccupied cell. This step is for occupied cell. We need to remember this. Start with assigning 0 to any row or column having maximum number of allocations. The maximum number of allocations more than one, then choose anyone arbitrarily. Okay. Now let us look at this one. So here we need to go to the second step, that is UI. Second step, that is UI and VJ method. What is UI and VJ? We need to find UIs and VJs for respective rows and columns. So we need to find U1, U2, U3 and V1, V2, V3 and V4 for all of these things. So before we start assigning what is V1 and V2, let us go back and see what the step says. Here in the step it says that assign 0 to any row or column having maximum number of allocations. If maximum allocations are more than one, then choose any one. Arbitrarily means any one you can choose. So we need to assign 0 to that row or column that have maximum number of allocations. What is maximum number of allocations? We need to see here. Now here in this particular column or row, we need to see how many allocations are there. One allocation. Here in this row, 2 allocations. Here in this row, 3 allocations. So this is 3. Here in this column we have 2, 1, 2, 1. So maximum number of allocations has happened to this particular row. So that's why we need to assign 0 to this particular row. Once we assign 0, we need to see how to solve the problem. Okay. Now they say that there is a formula here. The formula says ui plus vj is equal to cij. Now here you can see a formula, that is ui plus vj is equal to cij. How to do that? Let us see. Now Cij is equal to ui plus vj for all occupied cells only. This is very, very important. You have to do this one only for the occupied cells. How to do it? Occupied cells. These are the occupied cells. Okay. These are the unoccupied cells. The step number 3 and 4 talks about unoccupied cells. Now we are doing only for the occupied cells. How to do it? Now this U3 is 0. Now we need to see only the occupied cell. This is the occupied cell. The corresponding this thing is V1. So we need to find the value for this V1. How is V1 plus V3 is equal to 7? When this put together, V1 plus V3 is equal to 7, that means that this U3 is 0, U3 is 0, so 7 plus 0 is 7. So what is the value of V1? It is 7. 7 plus 0 is 7. This is the cost. This is Cij. Ui plus Vj is equal to Cij. This is Cij. This is the cost. C means cost. So 7. This value is 7. 7 plus 0 is equal to 7. In the same way, if you want to find V2, V2 plus V3 is equal to 6. So how much is V2? V2 is 6 plus 0 is equal to 6. So you can write 6 here. Similarly here, V3 plus U3 is equal to 6. So 6 plus 0 is equal to 6. You cannot do for this cell because it is an unoccupied cell. Because we are doing only for the occupied cell in this step. Okay. So how to find V4? We will do it later. So before this row is satisfied. Now we need to go for corresponding. V1 is there. We have the value of V1. With the help of V1, we can find U1. How to do that? V1 plus U1 is equal to 2. This is the Cij, the cost. So V1 is 7. So how much should be U1? So that you will get the total as 2. 7 minus 5 will give you 2. So U1 is minus 5. So 7 minus 5 you will get 2. Similarly, you cannot do for this cell because this is a unoccupied cell. We are doing for occupied. So this is already we have found out. Similarly, let's go for this one. There is also nothing here. For here, with this value, you can find value of this because this is an occupied cell here. So how to find this out? So to find this, V3 plus U2 is equal to 5. V3 is 6. 6 minus 1 will be 5. Similarly, you have got this one. With the help of U2, you can find the value of V4 because there is an occupied cell. You cannot do for the unoccupied cells. Okay? Occupied cell. V4 plus U2 is equal to 4. How much should be V4? V4 means 5 minus 1 is equal to 4. So you can have this number as 5. You will get it as 5. So in this way, you have done the second step. You have found all UIs and VJs for the occupied cell. So this is the completion of the second step. Now let's see what is there in the third step. Okay. The third step says for each empty or unoccupied cell, find UI and VJ return. Find the sum. Sum means total of UI and VJ written in the bottom left corner of the cell. Okay, we will do that. But this is for unoccupied cells. Okay, now let us do this. Okay, so now what they want us to do is they want us to write this UI plus VJ in the bottom left corner of the cell for all unoccupied cell. All unoccupied cells are nothing but empty cells. Empty cell, we need to do UI plus VJ and write it on the bottom left corner of the cell. Can we write for this one? No, because this is not an unoccupied cell or an empty cell. It is an occupied cell. So here we can write. Here UI plus VJ. UI plus VJ. That is 6 minus 5. It is 1. Where to write? Bottom left corner of the cell. Here you write. That is 1. Here you can write for this one also because it is unoccupied cell. 6 minus 5 again it is 1. Here you can write for this one also unoccupied cell. 5 minus 5 is 0. So in this way you have to write it. So this is also unoccupied cell. You can write 7 minus 1 is equal to 6. Here this is also unoccupied cell. 6 minus 1 is 5. These two are occupied cells, so we don't have to write for the occupied cell. Now again, this is occupied cell, this is occupied cell, this is occupied cell. This is an unoccupied cell. So we need to write for this one. So 5 plus 0 is equal to 5. We can write it here in the bottom left corner of the cell. So we have completed the third step. For all unoccupied cell, we have calculated ui plus vj and written on the bottom left corner of the cell. Now let us look at the next step. What is the next step? So the next step is, for each empty cell, that is again unoccupied cell, find out the net evaluation value, that is dij is equal to cij minus uij, and write it on the bottom right corner of the cell. This you have written on the left corner, this you write on the right corner of the cell. Okay, that is called as net evaluation value. Dij is equal to Cij minus ui plus vj for all empty cells. Now let us see how to do this. Okay, for all unoccupied cells, again, for all unoccupied cells, what you have to write is, find out is Cij, that is equal to, we have to find out Dij. How to find it out? That is Cij minus ui plus vj. Right? Now, this ui plus vj for all unoccupied cell, you have already done this. You have written it here. What is Cij? Cij is nothing but the cost, which is there in the center. So Cij is there in the center for all unoccupied cells. You don't have to do for occupied cells. You should not do this for occupied cells. You should do for unoccupied cells. So unoccupied cell, Cij's are there, which is written in the middle, and Cij's are there. Ui plus vj is written here. So Cij minus ui plus vj is 2 minus 1 is 1. 2 minus 1 is 1. 1 minus 0 is 1. 10 minus 6 is 4. 8 minus 5 is 3. Now this is the unoccupied cell. 8 minus 5 is 3. So you have got now all Dij's you have got. This is 1, 1, 4, 3, 1, 1, 1, 4, 3 and 3. These are the Dij's. So you have successfully completed this step. Now there is a last step which is remaining now. So let us look at what is the last step. There are conditions. So in the step 4, it gives you optimality conclusion in 3 different ways. If all Dij's are greater than 0, then the solution is optimal and unique. If Dij is greater than equal to 0, means if at least one Dij is equal to 0, then the solution is optimal but not unique. Means alternative solution exists. If at least any Dij is less than 0, then the solution is not optimal. So let us see what is there in this problem. Now here we need to see Dij's. Now see, Dij is greater than or equal, greater than 1, greater than 0, greater than 0, greater than 0, 4 greater than 0, 3 greater than 0, then 3 greater than 0. So all Dij's are greater than 0. That is the first condition. So once we have done the first condition, that is what we have got here is, so we have satisfied these conditions. All Dij is greater than 0, then the solution is optimal and unique. So what we can write here is, this solution what we have got is, therefore all Dij's greater than or equal, greater than 0, hence the solution is optimal and unique. So in this way you need to conclude the problem, and this will be your solution. So in this way, through this Modi method, we have found how to get the optimal solution. So thanks for watching. We'll continue in the next problems in the next video. Thank you.